Artificial intelligence systems may be able to complete tasks quickly, but that doesn't mean they always do so fairly. For instance, if a dataset contains mostly images of white men, then a facial recognition model trained with this data may be less accurate for women or people with different skin tones. A group of researchers at MIT, in collaboration with researchers at Harvard University and Fujitsu, Limited, sought to understand when and how a machine learning model is capable of overcoming this kind of dataset bias. They used an approach from neuroscience to study how training data affects whether an artificial neural network can learn to recognize objects it has not seen before. A neural network is a machine learning model that mimics the human brain in the way it contains layers of interconnected nodes, or neurons, that process data. The new results show that diversity in training data has a major influence on whether a neural network is able to overcome bias, but at the same time dataset diversity can degrade the network's performance. They also show that how a neural network is trained, and the specific types of neurons that emerge during the training process, can play a major role in whether it is able to overcome a biased dataset. A neural network can overcome dataset bias, which is encouraging. But the main takeaway here is that we need to take into account data diversity. We need to stop thinking that if you just collect a ton of raw data, that is going to get you somewhere. We need to be very careful about how we design datasets in the first place, says Xavier Boy, a research scientist in the Department of Brain and Cognitive Sciences, BCS, and the Center for Brains, Minds, and Machines, CBMM, and senior author of the paper. In neuroscience, Boy explains, it is common to use controlled datasets in experiments, meaning a dataset in which the researchers know as much as possible about the information it contains. In this case, a dataset had less diversity if it contains more images that show objects from only one viewpoint. A more diverse dataset had more images showing objects from multiple viewpoints. The researchers used these carefully constructed datasets to train a neural network for image classification, and then studied how well it was able to identify objects from viewpoints the network did not see during training, known as an out-of-distribution combination. For example, if researchers are training a model to classify cars in images, they want the model to learn what different cars look like. The researchers found that if the dataset is more diverse, if more images show objects from different viewpoints, the network is better able to generalize to new images or viewpoints. Data diversity is key to overcoming bias, Boy says. But it is not like more data diversity is always better. There is a tension here. When the neural network gets better at recognizing new things it hasn't seen, then it will become harder for it to recognize things it has already seen, he says. Testing training methods. The researchers also studied methods for training the neural network. In machine learning, it is common to train a network to perform multiple tasks at the same time. The idea is that if a relationship exists between the tasks, the network will learn to perform each one better if it learns them together. But the researchers found the opposite to be true. A model trained separately for each task was able to overcome bias far better than a model trained for both tasks together. The results were really striking. In fact, the first time we did this experiment, we thought it was a bug. It took us several weeks to realize it was a real result because it was so unexpected, he says. They dove deeper inside the neural networks to understand why this occurs. They found that neuron specialization seems to play a major role. When the neural network is trained to recognize objects in images, it appears that two types of neurons emerge. One that specializes in recognizing the object category and another that specializes in recognizing the viewpoint. When the network is trained to perform tasks separately, those specialized neurons are more prominent, Boy explains. But if a network is trained to do both tasks simultaneously, some neurons become diluted and don't specialize for one task. No one told the network to include these types of neurons in its architecture. That is the fascinating thing, he says. That is one area the researchers hope to explore with future work. They want to see if they can force a neural network to develop neurons with this specialization. They also want to apply their approach to more complex tasks, such as objects with complicated textures or varied illuminations. This work was supported, in part, by the National Science Foundation, a Google Faculty Research Award, the Toyota Research Institute, the Center for Brains, Minds, and Machines, Fujitsu Laboratories Limited, and the MIT SenseTime Alliance on Artificial Intelligence. Nature Machine Intelligence. 2022 doi. 10. 1038 per second 42256. 021, 00437, 5 Massachusetts Institute of Technology. Can machine learning models overcome biased datasets? Science Daily. https://ift. tt. neoh0c4. Accessed February 21, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.